Hello and welcome to this episode of the Primary Maths Podcast, the show where we talk all things primary maths with me, Jon Cripwell. And today, well, it's fair to say that few areas of maths spark as much debate or possibly headaches as times tables. We all agree that they matter, but how children actually develop fluency is a question that still divides opinion. In this episode, we are going to delve into the pedagogy behind multiplication facts, not just how to get pupils to remember their times tables, but also how to understand them and connect them. I'm delighted today to be joined by Cate Fearn, a primary teacher, primary educator, and the creator of Table Stick, a classroom tool designed to make multiplication practice more engaging and more sticky. Kate's got a fascinating story to tell, and I can't wait to hear it. We're also going to talk about what true fluency looks like, how conceptual understanding and recall can work together, and why joy, structure, and pedagogy all have a place in times tables teaching. So welcome, Cate. Thank you for joining us.
Thank you. Hi. Thank you so much for having me today. I'm really excited to chat with you all things times tables.
Absolutely. Yeah, thank you very much. So, Cate, I always like to ask, I think it just gives a little bit of context to the listeners. What was maths like for you at school? Have you always been passionate about maths? Was it your favourite subject at school, or did that come a little bit later?
Yeah, the absolute opposite, to be honest. I didn't have a good start in terms of my maths experience. I really didn't enjoy maths at all the whole way through school. Thankfully, in my final year of secondary, I had an amazing maths teacher who managed to get me to a point that I got the GCE that I needed to be able to teach. However, yeah, it was not a great story, to be honest, in terms of maths education. I was at school during the 70s and the 80s, and we were all basically given a textbook, and you worked your way through in silence. And if you got stuck, you got stuck. I'm not sure how you actually ever got unstuck, but we must have done at some point. So some people were on sort of 2, 3, 4 books ahead of me. And yeah, it was all about procedure and learning by rote, which at the time, I didn't really understand. That's why I struggled so much with maths. I needed to understand it. And I remember being really frustrated that I just didn't get it. Times tables was even a sorrier story, if I'm honest. It was purely about learning times tables by rote. We chanted. I can remember not being allowed home at the end of the day until I could recite my times tables. I can remember being pointed at in assembly and made to stand up in front of the whole school and asked times table. And then we chanted, we played games, and then we were tested. And surprisingly, I didn't do very well. I didn't realise at that time that just some people, some of us, just have a part of the brain that struggles with memorising maths facts. So I didn't understand at the time, so I just filled in the gaps myself and thought that maybe I'm just not very good at maths.
I think that's a surprisingly and sadly common story and experience,
Yes.
and still for some children today, even though we've made,
Absolutely.
I hope, great strides forward in terms of teaching maths and the experience of learning maths. But I think there's still children who feel very much, certainly anxious about it, and when they're picked on in class or God forbid, in front of the whole of school in assembly, that sounds particularly traumatic. And just the fact, Cate, that you remember it, a couple of years later, just a couple of years have passed since then.
Just a few years.
But the fact that it's still with you now, you can remember that.
Yeah.
I'm sure there's whole weeks and months of school that none of us can remember, but that sticks with you, that sort of experience.
Absolutely.
So,
Absolutely.
not what we would consider best practice now,
No.
I hope.
And it's really interesting, actually. Sorry. So I worked at Sheffield Hallam on an early maths for a while. And one of the first things I always like to do is kind of like to talk to the trainees about their attitude towards maths. And I would say 90% of the time it's really negative. And I would say that 95% of that time it's because of their experience of times table teaching or not teaching, the experience that they had and the trauma that they went through, which is colouring even still their their kind of like feelings towards maths. So yeah, it's still happening now, and I carried it quite strongly for a long time. Those feelings,
Yeah.
yeah.
And I can completely empathise with you. So my
Mm.
experience of primary school in the 80s and very early 90s, times table teaching, I would say, wasn't really a thing. We were just sort of expected to know them, and we would be tested on them, but
Yes.
never really taught them. So, and even that testing and checking was very, very patchy. So I remember one year, probably year 4, we did have weekly times tables
Mm.
tests in silence. Um, Funnily enough, though, from a teacher's point of view, we always used the same book. And we just had to write out our times tables in them. So obviously, I would be, as somebody who really struggled to remember their times tables,
Yes.
I would
Mm.
be constantly looking back at last week's and just copying out where I got to there, and
Yes.
then just trying to work out the next couple so that it looked like I'd learnt a couple more than I had
Yeah.
last week. But
Yeah.
none of that had really stuck. And we'll get on to later, I think, when we talk about memory and things, why that might be, and how we can cope with for people who might find rote memorization of times tables tricky,
Yes.
what coping strategies that we might have. But we know, so when we're talking, Kate, the curriculum and assessment review was released yesterday, and the recommendations, and one of them that the government seems to have taken on board, is that the multiplication times tables check will remain in year 4. Um,
Yes. Mm.
and they're going to try and improve some accessibility around that. But essentially, sounds like it's going to be the same. From my point of view, the MTC is an interesting one because whilst I think there are definite issues with how it is delivered and some confusion around what it means, in terms of accountability and what a good score is and that
Mm.
sort of thing. I
Mm.
think what it has done is focus schools' attention on making sure that there's some teaching of times tables by year 4, so that
Yes.
the children are able to access the times tables. But beyond the MTC, why do times tables still matter in 2025? Why should we bother spending the time with them, do you think?
Yeah. That's a great question, John. And I think it's really helpful to think of times tables and teaching and learning times tables similarly to how we think about phonics. So teaching times tables, that isn't the end point in itself. It's to allow children to then be able to unlock and access wider, more complex areas of maths, such as fractions, such as decimals and algebra and so on. So it's really so important that when we're teaching times tables, that yes, we want them to be able to rapidly recall the times tables, but we also want them to be deeply embedded so that moving forward, we can build on those facts and we can connect new facts to them. And it also, if we make a really good job of teaching times tables and we use a strategy-based approach and so on, we're also building that really rich number sense alongside developing that times table fluency, which, as we know, builds confidence and so on. So I think it's absolutely critical that we see times tables as a way for children to access their more complex areas of maths.
So not knowing them just for the sake of knowing them, but actually because they open the door to other areas of maths, as you say, and also
100%.
because is there an argument that it reduces that cognitive load when you're solving a multiplication or a division or a word problem or fractions or decimals, percentages,
100%.
all those things
Yes.
that all rely on multiplicative reasoning?
Yes.
There's a reduction in cognitive load, isn't there, if you are able to recall the times table without having to calculate it every time?
Yeah, 100%. So that's a really, really key point that we want children to have the facts at the fingertips. If that means using a strategy really, really quickly. So Jo Bowler, maths professor at Stanford, she admits, and I do the same, that I don't have the facts locked in using memory. I use a really, really quick strategy, and she does the same, and lots of us do that. So as long as we can use a strategy really, really quickly, so we've not got that overload for those of us who really struggle to memorize, then as long as we have got that rapid recall so that we're avoiding that cognitive overload, then absolutely that's really, really important, so that we can problem solve and we can use them to solve fraction problems and division and so on. Yeah.
Yeah.
Mm.
So, and that's interesting. And I want to get onto that in a moment if we can. That some of those
Mm.
strategies that maybe
Well,
children and adults
mm,
can use, that maybe adults do use, and children need
yes.
to learn to
Mm.
use. Because I'm in that same boat as well. Although my instant recall of most of my times tables is actually pretty good now from
Yes.
years of um, teaching them
Yes.
and also challenging children, in competitions with them and that sort of thing.
Absolutely.
I had to upskill. I remember at one point my traumatic experience, similar to yours, but I was an adult and a teacher and a
Mm.
maths lead and assistant head at the time, was standing at the front of assembly with the whole school and being having to as a celebration of times tables and
Yeah.
maths in general, racing one of the year sixes on a times table challenge in front of the school with everybody watching on the screen. The
Oh
year
God.
six obviously was chosen because they loved it and were brilliant
Yes.
at it.
Yeah.
And I think it was in reflection, it was good to see that the children could see that the teacher was fallible. Let's put it
Yes.
that way. Not necessarily the best in the room, but still able to access the maths.
Yeah.
So
Absolutely.
I think hopefully that's what they took from that. But yeah, I still remember that fear and that panic of,
Yes.
everybody's
Yeah.
watching, the children and the adults and everybody else, and I've got to try and, get these correct. So I think being able to empathise with the children sometimes is important. So is
Definitely.
that what you think of in terms of times table fluency then? Not necessarily just instantly
Mm.
knowing that 7 sevens are 49, but if I don't know what 8 sevens are, if I know 7 sevens, I can use those. Is that what we mean by fluency, or does it have to be instant recall and rote memorization?
Yeah. So if we look at the Maths National Curriculum and we look at the fluency aim, fluency sort of has become, since the MTC, almost used interchangeably for meaning rapid recall. However, if we do
Yeah,
look at the national curriculum, we can see that fluency is made up of three key strands. So we've got the efficiency strand. So we want that rapid recall, but we also want children to be able to choose efficient strategies that they might be able to use with very, very little effort to also get to the answer. So we want the efficiency, we want that rapid recall. We also want children to know and be able to explain how they know that they're accurate. So often I've heard children quite confidently sort of recall a fact, but when you say, how do you know, they have no idea, and actually what they've recalled is wrong. Um, so that's another sort of reason why a strategy approach is so important. So we're empowering children with strategies and that deeper understanding so that they're able to explain how they know that they're accurate. And then we have the flexibility strand. So children being able to apply those facts in different maths contexts. So again, when I'm doing training, the number of teachers who say, yeah, they can recall them in order, starting from 1 times to 12
yeah.
times. But if you ask them to use them in any way, they haven't got a clue. So it's that being able to apply what they know as well. So we've got the 3 strands of fluency, and all of those are underpinned by deep understanding, because how do children explain how they know they're accurate, or how are they able to apply them if they don't understand the maths, if they don't understand those facts? So that's kind of where I think we need to be thinking with fluency, of bringing together all of those 3 key strands and all of it underpinned with deep understanding.
And that makes, I'll completely agree, Kate, in terms of what fluency really means. I think it's often misconstrued as purely being about knowing your number facts, but actually, I think true fluency is much greater than that. And if we
Yes.
use the analogy of language as, I could know how to read certain words in French and things, but that doesn't mean that I'm fluent in the language if I can't
Yes.
use it to, to converse and to make implications and all those sorts of things, the things that you need a deeper understanding of the
Yes.
subject in order to be able to do,
Yes.
and to be accurate as well, as you
Mm,
say.
yeah.
So
Mm,
I in my experience of working with teachers and in schools, I think times tables is one of those areas where a lot of time is potentially spent on it, but much of that time is not spent learning them in the way that we would teach other areas of maths. So, for instance, if I was teaching addition, I would be thinking about using concrete manipulatives. I would be thinking about, what pictorial representations am I going to use here? I would be at a very basic level, I would just be checking that children understand that we can put two groups together and find a sum, and making sure that the language is secure and all of those things. When it
yes.
comes to times tables, the most often the practice that I see is chanting them or
Yeah.
possibly
Mm,
putting a video on that plays a song with the times tables in,
yes.
and then the rest of the time is spent testing them or practicing them,
Yes.
and not necessarily intelligent practice either. It's quite random often, although you might focus on one particular times table, I
Mm,
suppose. But in terms of actually teaching them, I think that's a skill that is, um, not as prevalent as it might be, let's say. So,
yeah.
I'm really interested, Kate, and I know this is an area of your expertise. How did children learn multiplication facts? And what if we're starting with counting in groups, for instance, to learn what multiplication is or
Yes.
repeated addition, how do we move from that basic stage to actually having fluent recall of my 7 times tables?
Yeah. First of all, that was so good to hear you say all of those things. I was wanting to go, yes, 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 to all of that. Oh, absolutely brilliant. So it starts early in foundation stage with children becoming familiar and understanding equal groups and making equal groups. Um, and then sort of looking at, we can add those equal groups and looking at repeated addition and then making the connection between repeated addition and multiplication. I always like to give an example. For example, if we had 75 lots of 5, if I had to write 75, add 75, add 75, add 70, no, 5, add 5, add 5, add 5, add 5, add 5, 75 times,
Yep.
I'd finish up running off my book onto the person's book next to me, onto the person's book next to them, and right up the way across the classroom. So we're really, in maths, we might like to make life a little bit easier. So we've got the time sign. So instead of having to do 5 add 5 add 5 add 5 add 5 75 times, we can just write 75 times 5. So
And
helping children.
that's a critical, concept, isn't it, for
Yes.
multiplication? Because
Mm,
having spent lots of years teaching in year 6,
mm,
I know that when it comes to working with fractions, for example,
mm.
and multiplying them, if we don't have a concept of actually what's happening when you multiply things, it becomes really complex. But
Yeah.
if you can actually think of, okay, 3 times 3/4 is just 3 lots of 3/4.
Yes.
Conceptually, that makes a lot more sense, and you
Yes.
can picture what that looks like. But
Yeah.
otherwise, it becomes very abstract very quickly, doesn't it?
100%. And the number of times, so sort of worked with children struggling with times tables, and I've said, okay, can you show me, for example, 3 times 5? And they'll, like with Numicon, so they'll get me a 3 shape and they'll get a 5 shape because they've not
Yeah.
understood that 3 times 5 means 5 add 5 add 5. Um, so that's a really critical connection that we need to help children make early on. And then we can move on to sort of helping children really see the patterns and the connections that exist in multiplication. So if we start thinking about the 5 times table, we can look that, for example, if we've got an even multiple of 5, we can see that that makes a group of 10. So if then we've got 4 lots of 5, we know it's going to make another multiple of 10. So then we can predict, what about 8 lots of 10? That's going to make another lot of 10, so it's going to have a 0 in the ones. Rather than just telling children the 5 times table, we've got the repeating pattern of 5, 0, 5, 0, we can actually dive deeply and see that by sort of creating with manipulatives, we can see those connections. When we look at the 2 times table, making the connection, for example, with doubling. So I've had children saying, oh, Miss Fearn, I'm learning my 2 times table. I said, brilliant. Do you know your doubles? And they look at me as if I've just asked them if they like cheese, some kind of totally irrelevant question, because we haven't helped them make that connection between seven lots of 2 being the same as 2 times 7 or 7 doubled, and really helping children make those connections. So then when children have become really secure and really mastered their 2s, 5s and 10s, we can start to use those as pegs, if you like, as landmarks to help them connect all the other times tables. So I sort of really advocate splitting or chunking each times table down into small groups of connected facts. So starting from a fact that children already know, those really key, I call them landmark facts. So 1 times, 10 times and 5 times. So if we look at, for example, 1 times, we can double it to help us find 2 times, double it to help us find 4 times, double it to help us find 8 times. And then we can go beyond 8 times to 16 times, because the number of children who think the world ends at 12 times and that we can't go beyond 12 times. I had a lovely story when I was working with some children struggling with times tables just after lockdown. They hadn't started using a strategy approach. I kind of introduced that with them. And I can remember asking them something like 14 times 7. And this little year 4 girl said to me, oh, Mrs. Fearn, my dad asked me that during lockdown. And I said to him, you can't trick me. I know that that's a red herring. I know you can't do that because you can't go past 12 times. And she's like, I know you can now. So I said, okay, how would you do it? And she said, well, I'd either do 10 times and 4 times, or I'd do 7 times and double it. And she just got it. Whereas a few sort of months earlier, she thought that you couldn't actually do 14 times 7. So it's so interesting. So we can use
It's
those.
funny, isn't it? It's funny to think about that the 12 times. I was just, as you were saying that there, I was thinking, okay, well, when I started teaching, we didn't even bother with 11 times and 12
No,
times. It was
no,
just up to 10 times.
yes,
When I was at school, it was 12 times. So at some point, we went and decided that you only needed to know up to 10 times. And
yes,
then we brought back the 11s and 12s. But for some reason, you just stop at 12, as if
yes,
that's all the facts that you could possibly ever need.
yes.
I don't quite know where the 12. Do you know what, Kate? I'm going to look into that. Why is it? Why is it 12s? We'll do an aftermaths episode on that.
Fabulous.
Yeah, it's
Yeah.
something to consider, isn't it? And not always, as you're saying, when you're teaching, just stopping at 12.
Yes.
We can go above that. It does exist.
Yes, absolutely. I've had it with children as well. It said like, oh, I know my 5 times table really, really well. It's like, brilliant. So what about, let's say a number like 83. Do we think 83 is in the 5 times table? And they say no. So I always ask why or how do you know? And so they said, no, it's not. So I said, okay, how? Like, why don't you think so? And they sort of, the eyes rolled back in the back of the head and they looked at me and said, because it's after 60. 83 is after 60. So it can't be in the 5 times table because 12 times 5 is 60. So again, it's like, so it seems to be quite prevalent that we think that,
Yeah.
it only goes to 12 times. Anyway, so from those key landmark facts, so we can teach times table in those groups of connected facts. So we're linking known to unknown. And then we can practice using really focused, direct practice, just those small groups of connected facts. We can apply them in different problem solving contexts and so on, making sure that we teach and children practice the associated division facts alongside that little group of connected facts. And then we can assess that small group of connected facts so that children are only sort of being assessed on maybe 4 facts at a time. And so that they're experienced in small steps of success rather than chanting, whatever, and then at the end of a week being assessed on 12 facts. It's kind of a
Yeah.
really slowing down and a breaking up into facts that make sense and a deep dive so that children becoming really, really secure and fluent with those facts in just small groups.
And that's critical as well, isn't it? Because that moving from just having the rote memorization of them means that if you do that, you've got 144 facts, haven't you, to learn in
Yes.
the
Yeah.
12 times, all the 12 times tables. But I
Yes.
think actually, in terms of unique facts, because of the commutative properties of multiplication, and if I know 7 times 5, then I also know 5 times 7. I think
Yes.
there's 66. Is that right? Something like that.
Yes.
I'm not asking
Mm.
you on the
Yes.
spot here, Kate, but
Yeah.
I think
Mm.
there's something like 66. So less than half. Actually,
Yes.
you need to know of those
Absolutely.
144 because
Mm.
you can use the related facts to work them
Yes.
out.
Yes.
Um, and you've mentioned the landmark ones uh, quite often already. I think that's how I coped as somebody who was of reasonable intelligence,
Yes. Mm.
but um, but struggled to remember times tables facts, partly
Yeah.
because I wasn't interested in them
Yeah.
as well. I didn't enjoy maths particularly at school. It's
Yes.
much more English based. I
Yes.
would sit and write stories for hours and read books for hours, but I
Mm.
wouldn't be, doing a Sudoku. So I didn't find them that interesting, I suppose. I found them much more interesting later when I learned actually how they worked,
Yes.
and how they could be used.
Yeah.
But
Mm.
I definitely coped by using those landmark things. So I found, I don't know if this is common, Kate, you could probably tell us, but I found um, square numbers.
Mm.
So 6 times 6, I could remember that as 36.
Yeah.
I knew 7 sevens were 49. I knew 5 fives. I could do those.
Yeah.
So I would use those, and I would work forwards or backwards by adding in
Mm.
order to get to the nearest. So if I was doing 9 times 7, I would well, later on I would probably do 10 times 7 and take away 7.
Yes.
Um, but before that, I might be doing 7 times 7 and adding on 14, which was a lot of work.
Yeah.
There's a lot of maths in there, isn't
Yeah.
there, and ways to go wrong. But it did help me because I could remember those ones. Is
Yeah.
that quite common? Is that a common sort of strategy to help children who struggle to remember all 66 or
Yeah. Using
144
the, do
facts?
you mean particularly using the square numbers or
Yeah,
using the
well,
lot?
just what might those landmark numbers be that you've mentioned? Are square
Yeah.
numbers common ones for those, or are
Yeah.
other ones more common?
So particularly, so when I'm doing training, lots of teachers say, to be honest, that they like to use the square numbers, and I think it's really helpful as well when we show children the square number as an array, and children have experience of making a square array to really help those square numbers stick. I think that's always like, oh wow, it makes a square.
Yeah, I think I was in my 30s before I realised why a square number was called a square
Yeah,
number. So, yeah,
absolutely. Yeah, same. Um, yeah, there wasn't any teaching for understanding when I was at school at all. It was just,
no.
you do this, you do this, you do this, you do this, and you get it or you don't. So yeah, I think it's really a massive light bulb moment when children see why a square number is called a square number. So they are really sticky facts for lots of children. And then we use it 10 times because of relation to 10 times table, and then the distributive laws. If we know 10 times, we can use that to help us find 11 times and 12 times, and then 9 times. And the same with 5 times. We can use our 5 times table to give us that landmark number, or we can half 10 times to give us 5 times, and then use that landmark to help us find facts nearby. So a little bit tricky. So 6 times and 7 times and 4 times. Some children prefer to double facts. Some children prefer to use landmarks. So it's a case of sharing the different but really key strategies so that children then decide which they prefer. Some will absolutely prefer doubling. Some will absolutely prefer to use landmarks. Some will use a mixture. Some will want to use the square numbers. But as long as it's efficient and they can explain and justify why they want to use that strategy, then that's great.
I think it's important as well, isn't it, that
Mm.
teachers model that. We've talked
Yeah,
about how
so
teachers, some teachers, lots of teachers might find times tables tricky, and when you're stood in front of a class of 30 children
yeah.
and sometimes some adults as well, and you know you've got to suddenly do a times table on the spot, you can feel under pressure that you're just supposed to instantly recall that. But actually, it's a great teaching opportunity, isn't it?
Absolutely. Yeah. And so this is what I used to use. So when I first started teaching, because I'd really struggled with learning my times tables by rote, I spent a lot of time really trying to explore ways to teach times tables to help children. So none of the children I was teaching would feel that horrible feeling that I felt. And I came across the Jill Manser video of using a counting stick with post-its. So that's
Yeah.
originally it was a wooden counting stick, but then it became a plastic counting stick with the post-its. And actually, it was really successful. And I absolutely loved teaching times tables, and because you'd see the light bulbs going on. So I think it's really, I would have a counting stick and some post-its handy at the front of my class, absolutely all the time. That's kind of what inspired me to then make a bespoke version. But I think that, yeah, we need to be modeling to children how we can use strategies to help us find those facts. Definitely.
Because also, and the added benefit of that sometimes as well is, I think we have to be particularly careful in maths that we're not just pulling numbers out of thin air, and children need to know where they've come from as well. So even though time is
Mm,
precious in any lesson, I
mm,
think it's always worth taking that time to just explain where I've pulled this, 6 times 6, where suddenly 36 has appeared from.
definitely.
That it's not just it's not just pulled out of thin air. There is a connection to the rest of the problem. So
Yes.
yeah, totally, really love that, Kate.
Mm,
So you've mentioned the counting stick, and I've used that as
mm.
well, and I've also seen those videos. There's a brilliant video. I don't know if it's the same one that you're talking of, where the I don't know if it's the same person even. I apologise. I'll try and find the link to the video. But they're teaching a group of students how to do the 17 times
Yeah.
table, I think, how to learn the 17 times table
Yeah.
using a counting stick. And it's just a great example of how you can make it fun and engaging, but really purposeful, and seeing that representation and the structure of the numbers as well using
Yes.
the counting stick.
Yes.
And I know on your site as well, you've got some links to your YouTube page where you model doing those things as well. So I'll make sure that I've got a link to that in the show notes, because it's really useful.
Thank
We've
you.
also mentioned arrays, and we've mentioned equal groups. Are there any other models that you would typically use with children to help them understand the structure of times tables?
I think early on, I think 10 frames are really useful to help children see the pattern of the 5 times table. Again, it works well alongside Numicon. I think both those are really useful representations so that children can see that when we've got an even number of fives, it fills the 10 frame. So we've got a full 10. When we've got an odd number of fives, we've got that 5 on its own filling the top row of a 10 frame. And we can sort of vary that using the same concept with Numicon. I think they're really two very, very useful manipulatives to use. And the same, we can use 10 frames to help children with the 2 times table. So I like to use a 10 frame as an array, if you like. So if you were looking at, for example, 6 times 2, so you've got 2 and 2, fill in a full 10 frame and then 2 more in a new 10 frame. So we can see without having to count, we've got a full 10 and 2 more. So we can see it's 12. And then if we spin the 10 frame or array around, we can see that we've got a 6 doubled. You can see we've got 2 lots of 6. So I
Yeah.
think 10 frames and arrays are really, really, really crucial. And Numicon I find really helpful for helping children see that connection between multiplication and division. So if we make, for example, 8 lots of 5, we can see that that makes 40. And then if we start with 40, we can see we've got 8 lots of 5. So really useful for helping children make those connections and see that structure as well.
And I think things like the counting stick, or those things with the tens frames and things, it doesn't. We're not talking about having to spend hours doing this, are we?
No.
There might be an argument for some intervention for children who are finding it particularly tricky to spend longer on. But
Yeah.
would you agree that kind of little and often is maybe a better approach with times tables?
Absolutely, 100%. So I think because we're looking at breaking each times table down into small groups of connected facts, just spending, I recommend 5 to 10 minutes a day if possible. Same as we would spend sort of spelling, reading, that kind of thing, because it
Yeah.
underpins so much later maths. It's absolutely critical, but I think a little bit often makes a difference. So, for example, if we're looking at 9 times, I always recommend making it with 10 frames. So if we're looking at 9 times 8, we'd make 10 times 8 with 10 frames. And then to look at 9 times, we'll look at that N10 frame, look that it's just a number bond of 10. So if we've got 10 and we take away 8, we can see we're left with 2. And then we've got
Yeah.
7 full 10 frames. And after we've done it with the concrete resources, then I get them to visualize it, talk to the partner and so on. So we're really deep diving into one little part of the 8 times table, just finding 9 times. So that might be 1 or 2 sessions, even 3 maybe, but just 5-minute little deep dives. And that really pays dividends, because then we can use exactly the same strategy for finding 9 times of any times table. And this is another thing that I'm finding, that when we slow down and go deeper, the facts are becoming really sticky. So then the next term, we're not having to relearn, or the next year go back. So the number of teachers in year 5, when I do training, who come to me and say, Kate, these children did so well in the year 4 MTC. And it's like now in year 5 that they've never even seen their times tables. And I need them to have them, to be able to access them, to look at these more complex areas of maths. And it's like they've never even seen the times tables, where if we slow down, go deeper, spend 5 minutes each day just looking at how to find 9 times, for example, for 2 or 3 sessions, then that's
Yeah.
time really well spent. We don't need to keep going back over that.
No, no, and yeah, I think that makes total sense, Kate.
Mm.
So, and it's interesting. Just while you were talking there, I was just sort of reflecting really on the progress that we've made in this area. I think with additive facts and understanding the structure and the composition of number.
Yeah,
In Key Stage 1 and early years, particularly
yeah,
early years, when you think about all the time that's spent there on understanding why 5 is 5 and how many different ways you can make 5 and take things away from 5, break it down and put it back
yeah,
together. It just feels like this is the next sort of conceptual step, really, to do the
yeah,
same thing with multiplication
yeah,
facts and those relationships, because they're so closely related. But it just doesn't seem to have quite taken off in the same way.
yeah,
Whether that will change now, because obviously the NCTM's
mm,
mastering number
mm,
focuses on this sort of multiplicative relationship quite a lot as well, and that seems to be being driven out across schools in Key Stage 2. And then
yeah,
also the curriculum and assessment review does mention a greater focus in Key Stage 2 on multiplicative reasoning
yeah,
as
mm,
being one of its key aims of the new curriculum
yeah,
when it eventually lands, which I think makes total sense
yeah.
given everything that we've said so far today.
I really hope so. Oh,
Time. Sorry,
sorry.
go on, Kate. Sorry.
No, I really hope so. It just feels so strange that with all the other areas of maths, we really dive deeply and we spend time helping children really understand number bonds, we get manipulatives out, we help children see the structure. But for times tables, it's almost like it's got an invisible ring fence around it that means that we don't have to apply any of that fantastic teaching to times tables. It's
Yeah, it's
strange.
strange. I think it's a real hang up from how children's parents learnt times
Yes.
tables and things as well. You know, that when people think of maths, I think quite often they think of chanting times tables and,
Yeah.
instant recall of times tables. And if you speak to my mum, for instance, she will have exactly the same memories of that, although she quite enjoyed maths and was very proud of knowing her times tables and things. But she has the same memories of being asked to stand up in class and give an answer with times tables and being able to do it, and that being a
Yeah.
proud memory for her. So I think, yeah, it seems to have been stuck in our psyche a little bit. We need to, as a culture, kind of move beyond that a little bit, if we can,
100%.
help parents to understand as well that,
Yes.
there's a bit more to it than that. Kate,
Yeah.
time is really against us a little bit now, and we've got so much more to say. And it could be that uh, we do a follow-up episode of this, just so that we can get into a few more things in a bit more detail. I
Yeah.
am interested, though, Kate, about how you've come to become such an expert in this field, and you've created a product to help teachers with teaching times tables, and you've worked in this for a number of years now. So is it okay? Do you mind just telling us a little bit about how you came to be doing what you're doing?
Sure. Yeah, yeah. So I absolutely loved teaching first and foremost, but the thing that I taught across from reception, Key Stage 1, Key Stage 2. But what I found, no matter which year group I taught, maths, very strangely, was my absolute favourite thing to teach. And I absolutely loved it. And those light bulb moments. Um, and so I decided that what I really would like to do, the path I'd like to go down, was to really dig deeper into what are those barriers to learning maths for some children. I think because that had been something that I'd really experienced as a child myself, I wanted to dig deeper because I was seeing so many children still really struggling with maths, and I wanted to know more about what are those barriers to learning maths. So I left my classroom and I decided to just work with groups of children, all sort of different schools all around the area, different groups of children, all who struggled with maths. And I spent quite a lot of years really taking a deep dive into that. And then it took another turn, and I was asked to work particularly with children who struggled with their times tables. So my counting stick came out. But I thought, you know what, this is actually still really abstract for some children. And as I was using the counting stick, there were sort of aspects that I wanted to be much more transparent for children. I wanted to help them see the connections clearer. And so I started to sow the seed of, I wanted to create something that did exactly what I wanted it to do. So I got involved with Design Futures actually at the university, at Sheffield Hallam University, and told them exactly what I wanted. And they put me in touch with a manufacturer, and we created a prototype, which I then took into lots of different schools, and it was trialled by lots and lots and lots of groups of children, lots of teachers. Then I had work group meetings with those children and those teachers, and we refined it. And then I spent years refining the actual approach, the strategy approach, to make it simple, because I wanted the power to be in the simplicity, and it all to be about helping children make use of connections to really help them see that we can use those known facts to connect unknown facts and so on. So yeah, that was my journey.
So it's amazing, but it is funny, as you say, how life takes these turns and
Yeah.
leads you down different pathways and
Yeah.
things. And just tell me a little bit more about the table stick.
Okay.
Is it something for use with whole classes or groups of children? How does it
Yeah.
work?
So it was really important to me that it was a really high quality resource, because I'd grown up with Pringle pots and takeaway cartons being used for maths and
Yeah.
incredible resources for English. So I wanted to try and address that balance a little bit. So I wanted it to be a really high quality resource. And to be honest, it did start life as a counting stick. The problem with this, apart from it not being very abstract still, was that I'd be in the middle of teaching using the Post-its, and then I'd see the
They fall
Post-its
off.
start
Yeah.
to fail, and I knew what was coming. And before I knew it, it
Yeah.
was like sort of eternal Narnia, where instead of it being winter all the time, it was autumn all the time, with the Post-its falling off like leaves. And also, two
Yeah.
children always had to have 11 and 12 stuck on the forehead. So I wanted to create something that was really high quality, really easy to use, didn't add to teacher workload. That was absolutely critical. That teachers would enjoy using, that children would enjoy using, that was engaging. So after sort of lots of tiling in schools and so on, I came up with this. So it's the cards are color coded and magnetic, so that
So just for anybody who's
yeah,
not watching, so if you are watching on YouTube, Kate has is demonstrating the table stick now on there, and absolutely have a look on there. But if you're just listening to this, it's sort of it's a very nice looking kind of looks like a meter ruler, I suppose, something like that, a bit thicker than a meter ruler, or a bit wider, I should say, than a meter ruler maybe. And it's got 1 times, 2 times, 3 times, 4 times. 5 times is in yellow and a little larger because that's a landmark one, I guess, Kate. Is that right?
yeah. So
And the same with
yeah,
10 times as well at the other end, and it goes up to 12 times.
yeah.
And then, did you say that there's cards that go on that are sort of magnetic?
Yeah. So we've got magnetic color-coded cards. So each times table is in a different color code, and they're magnetic. So the stick, the whole face is magnetic. So we can use it actually alongside. I've not got my magnetic Numicon with me, but we can put Numicon on there and so on. It's got detachable handle, so you can put it on your whiteboard. So I think it's really important that we actually draw those connections to help children see the connections between the facts. And so the whole idea is that we get those really key landmark facts in place first, and then we use these known facts to help children find the facts nearby that are a little bit tricky to start with, using the the color-coded magnetic times table cards alongside other key manipulatives such as 10 frames and Numicon and so on.
That's fascinating, and a resource I wish I'd had when I was teaching. And actually, I'm going to talk to you more about it afterwards, after we finish recording this, because it's it's fascinating. What a great
Thank
idea.
you. Thank you.
Kate, it has been fantastic talking to you this morning. I'm sorry we are running out of time now, I'm afraid. If people want to find out more about you and table sticks, where's the best place to go to?
Probably my website, just tablestick, www.tablestick.co.uk. So tablestick's got 2 S's in the middle because it's tables, because we've got multiple of them, and stick, as in we want them to stick, but it's also a stick. So it's tables and then stick. So some people struggle to find it because they only put 1 S in the middle. So it's 2 S's in the middle.
Lovely, brilliant. And I will put a link to it in the show notes anyway,
Thank
if anybody
you.
wants to
Thank you so
find that.
much.
For people listening, I hope that has been an interesting and useful dive into the pedagogy behind times tables. I'm sure we'll come back and look at it in a bit more depth as well. On Friday's episode, Becky and I will pull this apart a little bit more, and we'll take Becky's key takeaways from the episode in our Aftermaths episode that will come out on Friday. In the meantime, if you've got any questions that you would like to put to Kate, or any questions for myself or Becky, feel free to email primarymathspodcast@twinkle.co.uk. It's twinkle without an E, or send me a message on any of the social media platforms. You'll find me on there. Otherwise, thank you once again, Kate. It's been an absolute joy to talk to you this morning, and I'll look forward to seeing everybody else and hearing everybody else again next week. Thank you so much.
Thank you so much. I've really enjoyed that. Thanks, John.